Hello, Ian. I thought I would just go over some test corrections or assignment corrections, sorry, for you for this assignment. We haven't chatted in a while, so I thought this was the next best thing. For the first one, well, and for all of these, I know that in the content, it shows the two different ways of doing domain and range. But I really prefer, it's not wrong what you've done, but because at university they use exclusively the interval notation now, I would really prefer for you to write it in the interval notation. And so for all x real numbers, the x value greater than 3 that you're showing here in the set notation, it would be better for you to write it as this as an interval notation, round bracket for 3 to show that it's just greater than and not equal to, up to positive infinity, and round bracket again, okay? So the range will be the same thing. If the range is all real values, y equals all real values, then we're going to show that as negative infinity up to positive infinity like that. Oops, didn't mean to put that little extra loop on the infinity. Okay, so you're right, there is no y-intercept. There is a vertical asymptote at x equals 3. That's correct. The other thing that you were asked to complete in the question was the intervals of increase and decrease. And what that's referring to is where the slope is positive and where it's negative. And for this graph, if it goes like that, no matter where you draw a tangent line to this graph, you're always going to get a positive slope. And so you would say for this one, increasing for minus infinity to infinity. Sorry, my stylus is not sticking to my iPad here, okay? So you just say increasing for all values of x, basically. So for the second question, it's going to be the same thing, and I won't keep repeating myself about the interval notation, but you want to make sure that you use that notation because you'll need that at university or college, okay? You've got the x and the y-intercepts correct. The horizontal asymptote is also correct. I don't know what EOA stands for. I'm not sure what that means, but I'm sure you do, and it's a term that's probably used correctly, I'm sure. For this function, you have an interval of increase only because it's always going up. The slopes are always positive, and so you need to include that it's increasing for all values of x again, okay? In question 3, if b is going to be equal to 1, then that's actually not going to give us a log graph. It's going to just give us a horizontal line because we can only get, for the base 1, we can only get an answer of 1. And so that one's not going to grow exponentially, and so we can't show that as a log graph. For question 4, it's the same idea going back to question 3. Both of these graphs will end up being the same horizontal line, and so the only time that two lines won't intersect is not because they're opposite. It would only be because they're parallel. And in this case, the lines are not parallel. They'll actually end up being the same line. If we let b equal 1, question 5 looks good. For question 6, if you want the point 1, 1/2 to be on the line, I think the log equation is going to give you the point 1/2, 1, sort of the other way around. I think if you have y equals 1/2 to the x, that would give you the ordered pair 1, 1/2. So you've got the right idea there, but you've got to kind of reverse your thinking and use the inverse function from the log, which is the exponential function. So if you want to just go over some of those things, they're not a lot of them are not, corrections or mistakes. They're just a different way of doing it, sort of a preferred way of doing it. And question 1 and 2, don't forget about the increasing and decreasing intervals, though. And then just go over a couple of things in the last part of the test there as you're moving through this unit so that you know it for the test. And email me if you want some more explanation, okay?